Yeah, thank you very much for the invitation. So, as you said, my name is Alexander Schlemmer and I work for IndiScale GmbH from Göttingen in Germany, a company which I also co-founded a few years ago. And the company essentially provides services for open source research data management and also originated from a scientific environment. So many of us were scientists previously and basically designed our systems in a way that they work for us during daily research. And now we are like doing professional data management and providing data management services for other scientists and scientific institutions. So very specifically, there's a software called Link Ahead, which is visible here. I will talk very briefly about that today, actually. And most of the time, I will talk about our crawling framework. So the crawling framework is essentially our data integration tool. More is coming soon. And yeah, many of our customers actually use Link Ahead in combination with an electronic lab notebook, for example, eLabFTW or Kali format or something like this. So in several projects, we are actually working on improving interoperability between these systems. So electronic lab notebooks and other research data management systems like Link Ahead. And in one of my recent projects, I had to extend our data integration tool, so the crawler, how we call it, with an RO crate and ELN file format component. And this will basically be the topic of my talk today. And yeah, as you can guess, maybe from the title already, at some slides it might become a little bit technical. So I hope if it's too technical, we can dive into more details later in the question and answer session. But I try to kind of get a good mixture between technical slides and non-technical slides. So I hope there's something in this talk for everyone. So let's maybe start with some advertisement. So I will be also talking or also demonstrating the whole system at a conference in February in Karlsruhe at the Karlsruhe Institute of Technology. There is taking place a German conference for research software engineering. And we will show how to bridge repositories, basically to connect ELNs and semantic data management as it can be done with Link Ahead. And taking a use case for 3D additive manufacturing. And we'll be showing how to integrate and connect eLabFTW, Kali format, and Kmotion. So yeah, if you want to have more info, you can look at the conference webpage. So I don't know the background of the audience, but there might be some people also dealing with data integration. And at least for me, the story typically starts with a pile of data like this one here. So I get the task to integrate a lot of data into like a database or our data management system. And yeah, then it's my task to somehow organize this in a way that it can be made fair, essentially, so it can be made findable and accessible by the scientist and used, for example, in automatic data analysis tools. So, and this pile of data might contain ELN files. So this is just one piece that I need for doing the whole data integration. And later we will integrate this data, for example, as shown here, into Link Ahead. So this would be a snapshot of some data extracted from an ELN file in our system. So yeah, you probably have seen this figure before, or a similar figure showing a data management life cycle. So actually, I think this is kind of an over-idealized picture of reality. So typically, it does not necessarily only go in circles, but there might also be interactions between all of these components. But this figure, I would say, helps us to categorize data management software a little bit. So here on in the bottom right, we have the lab data, which involves using electronic lab notebooks. And yeah, it's typically involved, might be also involved in the step of doing numerical simulations, but mostly, of course, with your experimental results. Yeah, on the other hand, there's also here, I mentioned publications and data analysis. Of course, these files might end up in big data repositories, or even on just on data repositories connected to the journal's web pages. And now where would we put link ahead? So link ahead is kind of in between, we mostly say. So link ahead is not a very good ELN. There are many ELNs that can do tasks needed for data acquisition much better than link ahead. But link ahead is especially made for assisting researchers during work on what we would call living data. So data that is also subject to changes, like the output from data analysis, for example, or even for output from data analysis results, and so on and so on. So link ahead. So the main differences between link ahead and ELNs, I would say link ahead can be used to make data more findable, to link data, for example, from an ELN with data from simulations or even other kinds of data. And one of the main features is also to provide a semantic data management interface to support semantic queries. Like here, for example, this is actually an excerpt of, or one example for our search language that is integrated there. We can find very specific data types, in this case called a data set, which might be referenced by simulation with a special property like recording equals 15. So this is what we would call a semantic search. So the system itself needs to infer what types are used here and how they are connected. So this is very similar as doing a search, for example, in an ontology system or in a graph database, for example. Okay, so just a few facts. By the way, I see there is something happening in the chat where I'm not watching continuously. Okay, it's basically only greetings right now. So if there are questions, you should maybe raise your voice, because I will not be continuously looking at the chat window. So link ahead, as I mentioned, we were all, or many of us were scientists in Göttingen here at the Max Planck Institute for Dynamics and Self-Organization, and most of us were dealing with the physics of complex systems. And that was the environment where we initially developed link ahead. Later, we released it as open source software under a quite strict copyleft license, AGPL version 3 in 2018. And the address is still valid. So you can download the source code there and run the system yourself and improve it and develop with us together on it. And since a few years, we have this company, IndyScale GmbH, which was founded to provide commercial support, maintenance, and also development for this software link ahead, and also other open source software related to scientific data management. Yeah, this is just an excerpt for some examples for our customers. There are very different types of institutes that use our software, quite a lot actually from geoscientific community, like the Alfred Wegener Institute and the GEOMA, but also from other scientific disciplines such as medicine in this case, for example. So yeah, let's get back to our example with that pile of data and the task of integrating ELN files into a research data management system. So yeah, I actually found myself by far too often in the situation when using a database management system that I kind of had to manually import data. Of course, this very often becomes unfeasible. So we had to switch to custom scripting in many cases by using APIs, for example, for automatically importing data from the disk into research data management systems. However, I think many have probably experienced the situation that these custom scripts can be very tedious to use. And if you don't start to develop them in a way that they can be maintained properly and used in a sustainable way, maintenance of these data integration tools becomes more and more difficult over time. And also we found that we were using specific parts of the software, of the data integration software over and over again. And so we kind of felt the need to standardize this more and to create something that contained more reusable components, such that our data integration tasks could become much more efficient. And that's when we came up with the idea of creating a standardized crawler framework, which is a little bit maybe based on the custom scripting idea, but is designed in a way that it contains more building blocks that can be connected together in order to provide like a standardized tool chain for data integration. And that's what we then later called the link ahead crawler. Yeah, this icon is still work in progress. I hope you like it. It's basically our open source tool for data integration. One major difference between this tool and many other data integration tools I have seen is that it allows for inserts and updates. So it does not only allow for a data ingest into our system, so run the script or the framework one time and let it pick up all the data and insert that into the database management system, but also to detect the difference between what is found on disk and what is found on the target system, and then do the proper updating procedures. So this is one thing I will maybe talk a little bit about later also. So, the system was designed to be highly customizable. So as I said, there are a lot of standard building blocks that can be combined in a way to support typical tasks in daily data integration, so to say, but also to include custom procedures, for example, to open very custom file formats or to dive very deeply into the data in order to extract specific metadata or do some initial processing. But the main task is to scan the file system and synchronize the result of it with link ahead. I always use the term file system here to make it a bit simpler, but to be honest, it can also use other sources like non-standard file system storages and also crawl APIs or web sources, for example. But the main use case is file systems. If you're interested, I put the QR codes here for the source code and also for a scientific paper we have written about it. So in the paper, you can read more about the motivation and also like the context in the software environment. So we, of course, also did research on what tools were available and what similarities and differences exist between this tool and other data integration tools. So this can be found here in the paper. I'll also provide the plain text link later in this presentation. So coming back to our example, so the situation is like this, that we might have some kind of a folder structure with files, and very specifically, as we can, of course, have any files in there, but the main thing to add during this project was to add support for this file format here. So the presentation dataset.eln, it's called in our example, and this dataset just contains some very boring example data here, a voltage, a rating, an author, and that's it. So the task of our crawler now is to scan this structure, detect specific patterns in the form of specific files, and then create the appropriate representation in link ahead and do insert and updates. This can be done in a manual way or in an automatic way. So you can either press a button, let the crawler run on a specific source, or you can configure it in a way that it is continuously run and continuously updating changes from disk. Yeah, just to add some more details here. So for example, an update would mean in this case that the crawler runs over the structure again, detects this data set, checks in the database whether a file with these features found here is already present, and then only update the fields that might have changed. So it, for example, could be one use case that you are actually want to export this file again from your electronic lab notebook because mistaken the data was corrected or some additional information was added. And this procedure with the synchronization would allow you to keep also the records in link ahead up to date for later use. Okay, so coming back to this file structure. So I don't know whether everyone is familiar here with the ELN file format. I have not a particular slide about that, but I want to mention briefly that the ELN file format was developed by a consortium of people who develop ELN software. To specifically support interoperability between these ELN systems. And the file format itself is very much based on the O-Crate format, which you might have heard of. This is basically a container format for scientific data, along with a standard on what information needs to be present to ensure proper usage within scientific environments. So during the development of our crawler extension for supporting ELN file formats, we wanted to reuse as many components as possible. So I based this crawling component on a Python package that supports the O-Crate specification out of the box, and extended it a little bit to also get along with ELN files, which is actually not so much different. So by having integrated these two converters into our crawler now, these extensions, we are now able to support our O-Crate and ELN file format out of the box. So I've talked. So this is now the technical part. I excuse myself a little bit because it contains some technical terms like the YAML format, which is a plain text format for storing human and machine readable information. So that's what we based our configuration of the crawler on. And something you might need to know can be seen here, which is a regular expression, which is needed to detect patterns in file names, but and also folder names and other information. So there's a question in the Q&A. Okay, let's maybe get back to that later. So let's briefly walk through that example. So the YAML file, the configuration for the crawler, is a hierarchical mapping between stuff found on the file system and the records contained in our research database management system. So in the first level of the example shown here, we can see that we have a converter that matches directories, and specifically match directories that have a very specific name, in this case, experimental data. So as soon as we have seen here, okay, we actually have a folder, experimental data. As soon as such a folder is found, it will traverse the subdirectory and also match directories with a very specific pattern. In this case, that consists of a 4-digit number, an underscore, and some arbitrary name. And as you can see in the previous slide, this folder, for example, would match that specification in this folder as well. So as long as you keep your data in sync with that specification, you are able to run this crawler on your data. And as a last step, in this small example, we create records. In this case, we could create a project with a year directly derived from the name of the folder and a name directly derived from the second part of the folder name. So this simple example will create records and keep them in sync in link ahead derived from folder names. Of course, this is not so exciting yet, but you can probably guess that this task of scanning files, folders, and folder hierarchies is something very common because a lot of people actually store metadata inside of file names, folder names, and actually many people, at least in well-organized labs, also try to establish some kind of standard file structure, so a naming convention for their files and folders, such that it would be actually possible to create something like this and allow it to interpret what is stored on the file system. Okay, so let's have a look at our specific use case here. So I created in the demo instance of Kadi format, I created a very simple record, just having a voltage parameter here and a rating and an author, of course. And what I did was, in order to be able to test it, to export an ELN file. And then I needed to create that crawler extension and let it run on the ELN file. So this again, the more technical slides here. This is the configuration for a subtree that matches contents of ELN files. So our crawler is not only able to traverse file systems and their contents and make sense of it, it's also able to open these files and to use any contents within these files according to the specification you create. And in this case, I match an ELN file. So this is the extension I created with a very specific name. And extract just one data set out of it, which is an RO crate entity. So one element contained in the ELN container of type person that has a name and a URL, and create a record out of it that also is of type author in link ahead and has the URL and the name. And later on, I also add a number, but this is not important here. So by using these components, we can extract any information from within the ELN file and make use of it within our data model in link ahead. So this is the main idea of the crawling system, to have these building blocks that can be combined to extract and use arbitrary information from, for example, ELN files and synchronize them into, for example, link ahead. So our workflow in this case would be to export these ELN files, let the crawler run, and create the data sets contained in there. Yeah, and with that information, I would like to thank you and start with the discussion. So if you want to get more information about the whole system, so this is our company's webpage. This is the repository for all of the code related to link ahead. So link ahead, and as a sub-repository, the link ahead crawler. The link ahead crawler extensions can also be found there. And also many examples for crawler configurations for existing systems. And as I mentioned, the scientific article about the crawler framework, its motivation and its context can be found here. Yeah, thank you very much.
Thanks so much, Alexander. We have 3 questions. Are you able to see those?
Yeah, take a look.
I'll let you go through them, and then we'll switch to the second part of the session. Thanks.
Yeah. So maybe the first question is already a quite tough one. I hope it's not a bug, but which public demo are you referring to? Is this the demo.indiescale.com? Because I cannot remember that we have added the ELN demo already there.
Alexander, do you want to add more information? Oh, yes. Okay, so we have the link there to where that message was found.
Okay. Yeah, I probably would need to have a look in there because I myself didn't integrate the ELN export for this. So probably if the crawler has no matching rules for and is ignoring this file, it means that the extension for parsing these files hasn't been installed in the crawler system yet. So this is something that the question is maybe related to. So you probably are aware of the fact that every, or at least right now, every electronic lab notebook can, of course, introduce their own types and structures that would be stored inside the container format ELN. So meaning that the names and also basically the ontology or the data model behind what is stored inside an ELN file can vary between different formats. And that's why the crawler framework itself does not provide a standard way to open ELN files, so to say, but needs to be configured in a way that it would make sense for the use case that the ELN, the electronic lab notebook, is used in, and also that a link ahead is used in, because every data management system or most data management systems can provide a custom data model.
I'm just realizing that the participants can't actually see the question, so I'm just going to read that question. It was from Alexander Haller, and they said, is the public demo not up to date? It says no rules for ELN files, and then there's a warning message that says the crawler has no matching rules and is thus ignoring a certain file. And so this is just about whether or not the public demo can actually work at this point with ELN files.
Yeah, so the crawler extension for ELN files itself is pretty new. So I think I completed it just beginning of this year or so. So yeah, there might be some glitches still and some testing needed to finalize that. So the second question is, does the crawler only work on the string of the file names, or does it also utilize file attributes like creation date, owner, etc.? Yes, that's a very good question. So the crawler is in principle able to extract any information from any file, and it does this using the standards provided in the building blocks. So, for example, for directory and file, it's configured it's right now configured to match names, but in principle, it can be tuned to extract any information from these files, including creation date, owner, and also other file attributes. It can basically run any command you want. It's written in Python, so the most straightforward way would be to provide a custom Python module to do that, and then connect it to the record type structure found in link ahead. So we typically, I would say, most of the time we use and adapt the building blocks that are already there. But for most use cases, there's at least one custom module that uses some custom data format, like, for example, HDF files that can be opened and information extracted from them, or any other kind of file type.
Okay, great. Let's do this one last question, also from Alexander Haller. It's can you make decisions based on which ELN created the ELN file to map the metadata?
Can you make decisions based on... I'm not sure whether I understood the question correctly. So you think about... okay, you want to say, as you have multiple ELN files from different sources, basically, which contain different types of metadata. Is that right? Yes, of course, that's possible to do. As you can include distinctions between different files, and the most straightforward way would be to match specific contents of the file, like for example the source address that is contained, I think, in most of the ELN files I've seen so far. Of course, you would need to have of course, you like the type, for example. Yeah. So no one can see it except for me, right? So Alexander Haller is typing that there is a type attribute within the ELN files that contains the name of the software, in this case, eLabFTW in a specific version. And you could use that information from the file to match that, and based on that, do a different processing of the contents and a different mapping to link ahead. So.
I just wanted to make sure, I think we missed a question from Manuel Lerra Ramirez. Is the crawler suitable to sync data with a database that is not the one you are working with? For example, we answered that already, or it's yes, yes.
It has not been answered yet. Sorry, I think it was moved accidentally to the answering section. So yes, the crawler is designed in a way that it can be used completely independent of link ahead itself. We actually, because we work most of the time with link ahead, we haven't used it in like production use cases for this use case. But I have several experimental use cases. So in order to be able to answer that question, so we designed it in a way that it can be used independently. So in fact, also the specific crawler components. So there is one thing that is called the scanner that is specifically designed to just look at your file structure and extract the information in the way it is given in the configuration. So, and if you load that module and use it within your custom Python script, you can use the extracted information to output this data into a completely, or export this data into a completely different data management system. So I had actually tried, I think it was an SQLite database. So I created a specific SQLite relational database scheme, and then I used the information I got from this to export into that database. And the second component in the crawler, the second big component is the synchronization component that synchronizes the result of the scanner with a link ahead instance. And this one can also be tuned to connect to a different system. However, I have never tried it. So right now, also it's modular, so you can replace the part that executes in the API commands for link ahead. You can replace them using a different system, but I have never tried that so far. So this would be subject to testing.
Great. Well, thanks for that. It seems really interesting. And as there are just so many different systems and repositories being created, it seems like this kind of device is super useful. So excellent. Okay, well, thank you, Alexander. And now let's move on to
thank you very much.
Nico. Yeah, thanks. And if anyone, I'll just say now, if anyone has an idea for a future talk that they would like to give at the community meetings, you can just contact me directly. And like, we're always interested to learn what kind of special ways you are working with eLabFTW and ways in which you have customized your workflow and devices that you've developed that work with the software, etc. So yeah, okay, so now let's go to Nico, and yeah, I'm excited to hear what you're going to say.
Yeah, thank you, Sydney. So basically, I just wanted to show you a bit what we've been working on in the past weeks, so that you can get the view of the future version, basically, and also maybe give us some quick input back on the things that we are building. So one core aspect of the next version will be better support for chemical structures, chemical compounds. And so there is this page which lists compounds. So compounds are chemical compounds, and they have specific properties such as a CAS number, such as a molecular formula, molecular weight, smiles representation, INCHI key, and some other properties. So when you arrive and you have like an empty compound page, you can import them from PubChem. And so the import goes through the CID, the unique numerical ID that exists on PubChem. And so you can search for something. And let's pick this one, for instance. So it shows you what you are going to import. So I'm importing this compound inside my compound database, which is common for everyone. So we did not put any permission system on the compounds. The idea really is that everyone has read access to the compound. And once you have a compound, once you have added a compound, you can still edit it further if needed. For instance, if the import script didn't find some attributes and you can add them manually. There is also some safety information that is some of them, they can be read from PubChem. Some other you will have to manually make them. So for instance, if it's a drug precursor or if it's a CMR, you can check this box. And for this other box also, I will check them so that we will see the little icons. And this is just some immutable information. So we still keep track of who is the owner and in which team it was added. So we have this compound now. And now what I'm going to do is I'm going to create a resource from this compound. And this resource will be of the category chemical compound inside this team. And this resource now that exists in my database, this one I can play with the visibility. I can add more information. I can add some files. I can like any other resource that you're used to. The only difference is that this resource is linked with this compound. Note that you can link to several compounds. So if you have a mix, if you have a bottle with a mix of 2 or 3 compounds, you can reference them in there. And so this is just the information of the compound. And what you can do also is add containers linked to that resource. So a container is a quantity of the product. So in that case, you have a number and then you have the units. So the units can be macroliter, milliliter, liters, microgram, milligram, gram, kilogram. Normally, it should cover every kind of units you might want to store somewhere in the labs. This is just a multiplier so that, for instance, if you have 10 bottles of 1 liter, you can say it's 1 liter, but you have 10 of them. And then you say, so there is a structure that is created beforehand with all the different buildings, floors, rooms, even cupboard, or you can go to an arbitrary number of deepness, I would say. And you can, so you select where you are storing this thing. So in that case, I have 10 containers of 1 liter stored on the second floor of the hospital in the Paris site. And this container, you can change the quantity or the unit here, or you can remove the container if it doesn't exist anymore. And so this means that we now have also a storage browser, so basically a way to find things in the unit, in the instance, in the eLab thing. And so you can just type the name of something you're looking for, or type the name of the place that you're looking for to see what is in there, or you can browse also here and display the content of a specific room or building or whatever to see what is in there. And there is also the possibility to generate a CSV report. So there is a CSV report here from the things that you can see as your user in a specific team. And on the sysadmin panel, there is also the possibility to get a complete storage CSV that will contain everything, especially the hazardous properties such as is a drug precursor, or is a cancerogen, etc., etc. So new tools to work with compounds and to work with the storage of these compounds and this whatever else also, because if you're not a chemistry lab, if you're never working with cast number, you don't care at all about this, you can still have your resources that you store in containers so that you know where they are and you don't have to use the compounds. It's totally uncorrelated options, even if I show them together. There is also another new aspect of the software, which is that we removed the old chemical structure editor that was present in the below, in edit mode. So now it is on a dedicated page, and as you can see, it is a much better chemical editor than the one that was present before. And so this will need for the sysadmins in the room to deploy also a side container. In fact, two side containers. You can do substructure search. So you can draw something, then you click search, and it will search inside all the compounds that exist in there. And so if I get it a bit more specific by adding something here, we can see here we have our pyridostigmine, which has a structure that looks partially like this. So we are still in the process of making the user interface and the user experience better, so that you can then find where in the lab you have such entries that are linked with that given compound. But the idea is that you have a dedicated editor on which you can draw your molecules and search locally in your local database what are the resources, what are the compounds that exist in there. Probably what I will add is that when you click search compound, it shows you the compounds in the compound database, but also a list of resources that are linked with a given compound, or maybe if you double click a specific compound, you will find it. Or anyway, we will see, and it will, in any case, it's never something that is not moving, meaning that if there are some amelioration to add later, we can always add other amelioration later. So there is even a 3D viewer, which I think is pretty cool. And you also have the possibility to import and export in many file formats. So as you can see here, you have all these file formats that are available for exporting that structure, but you can also import from different file formats. So I think this is pretty nice. And so yeah, so that's the chemical editor, and there is also something else. So it's still a work in progress, but basically we integrate the tool called Share Your Cloning, which is developed by Manuel Lerra Ramirez, which is present in the room. So currently it's still a work in progress, and so that's why we still have this kind of error here. But it's a super cool software that allows you to do some DNA or RNA cloning or operations. Let's use the generic term operation. So for instance, you can pick some plasmid from a gene, and so it will fetch the plasmid sequence from a gene, and then you can say, okay, so now we'll do a restriction operation on it, and so it does everything that it needs to do, and so yeah, probably Manu can show you better all the things that it can do, but the idea really is that you describe all your cloning steps with that tool, and then it's still a work in progress, but the idea is that you will be able to save all of this as JSON file and maybe just simply link it to an existing experiment or to an existing plasmid resource maybe that you can have in your lab, so that you have the full history of how you created this particular plasmid or piece of DNA. And that you can maybe also continue, and when you share it, you will also have this history that is inside in the .eln file that you will share with your colleagues. So yeah, that's something that's coming also in the new version. And apart from this big thing, there are also many little ameliorations that some of them you will not see, and some of them will just be, this little quality of life improvement. Because when you tell us, when we do that, it would be nice if we could do that. We listen to you, even if sometimes it can take a few months for us to actually implement what you tell us. We really listen to user feedback to improve the UX of the application. So I will stop here. I see that there are already quite a few stuff in the Q&A. So Benjamin, can I search the storage browser with cast number or smiles? Names can be difficult in chemistry. Indeed, they can. So let's try this. So because I don't remember if I have implemented it or not. So this is my cast number. I'm copying it. By the way, I can just click also this button so that it will be copied in my clipboard right away. And then I go to storage browser. In fact, it's not really in the storage browser that you can find it. If you are on the resource page, you can type the cast number directly in that research field, and as you can see, it will find all the resources associated with a compound that has this cast number. So you don't have to go to the storage browser; it will show up here. But I agree that it should also pop up in the storage browser. Okay, so can the compound stock be imported with CSV? So yes, I didn't show it because currently it's only in command line interface. But yes, there is a function to import all the compounds that you already have in maybe some other old school database. And so it will map some fields, like if there is a column that is called smiles and contains the smiles, it will also import it properly. So currently it's only in the command line interface because I guess it's not really something that people will often do, like you do once a big import. But maybe later it can be also included inside the web interface. Benjamin DL, regarding the new container and location feature, would it be possible to update several resources entries at the same time? That would be great to facilitate migration of existing data. So I guess for this, the best would be to use the API so that you can script something instead of doing it manually. But I think it could be totally something that could exist here in the batch action, where you say, okay, so basically all my plasmids, so I'm selecting here all the resources that have the category plasmid, and here you can imagine some button here to add container, and this way it will add all your plasmid inside the same box. So I think this could be added, but it won't be added for now. Alexander looks promising. Will there be a feature where you optionally automatically can subtract used chemical from storage when you use them up in experiment? Yeah, so that's something that we have in mind. At least the first step was to get an idea of how much and where. And probably, yeah, the next step would be to make it easy to subtract some quantity. Automatically, I think it's a bit difficult, but we can see what could be done. Clemence Mangler, can one set consumption quantities of stored resources, ideally via the API? For instance, if one takes out a bottle or something. So no, so set consumption quantities of stored resources, like a limit, I guess, a limit of something. Though no, currently it's not limited, and this kind of feedback is really something that we will look forward in a second phase once we have the basics right. Can one set different container, boxes, bottle, packs? Yeah, so basically in the storage, so it happens in the sysadmin panel for now. And so here you have the possibility to add children two different places. And so we are not set yet on what will be the permission system for this. Like, can you, so what we have in mind, for instance, is that we can say, okay, so all the second floor of the hospital, anyone that is part of team B and team C can add children to it. The other cannot see it or cannot browse it. So we will see, because we have to find a balance between advanced permission system and also the easiness of working with it. So it's not evident what should be the correct permission system for that. But yeah, I think it would be most useful if anyone in the lab can simply add a box or a fridge or whatever if it's missing, instead of having to ask the admin or even the sysadmin. And a default consumable quantity. Yeah, okay. Gerhard Eisenberger, we always need the SDS file security datasheet for to every chemicals we use. Can the chemical tool automatically import the needed SDS file to the chemical resource? So the SDS file are provided by the reseller, by Sigma Aldrich, for instance. So on PubChem, there is no such information. There is information, but it's compiled from other database and it's associated with a degree of trust. So basically, the real security data sheet is the one that the entity that sold you that chemical tells you how it is. And because it depends on the purity, it depends on many aspects. So no, we cannot import it automatically. At least for now. So we import the flags, like, is it corrosive? Is it toxic to health or toxic to environment or oxidizing or etc. etc. But we cannot automatically import the SDS because it's just not something that is present on PubChem. So you will have to add them when you have your resource. You add the SDS PDF as an attachment. John, how can you follow up the usage of your chemical? Because now you make adaptation to what is available, but you cannot follow up how much was used in the past. So yeah, it's true that the history of what was added, what was removed, I think would be interesting. So for that, I guess we can have, like, similar to what we have for the experiments or for the resource, a change log. And the change log will just list all the operations that happened on a container. And so yeah, for the moment, we don't have the history of what happened. Yeah. And I think it will be especially important for dangerous products. Okay.
There's a few more questions in the chat and some comments.
Yeah, but Josh is saying that the storage browser makes him think of data storage such as S3 or file system, maybe physical inventory or something similar. I don't know what the other think, but storage browser, unless you are a geek, it means you store, this is the browser where you store the stuff. But I think it's a little deformation of your technical knowledge that makes you think of this, and the rest of the people, I guess, don't have this. But maybe I'm wrong. Maybe it should be renamed.
We should discuss it.
We can make a poll.
Yeah.
We rename this?
Because for me, I agree. Physical inventory is like super clear that you're talking about a thing in real life, whereas
Okay.
storage can just mean like
Just inventory, maybe, no?
I think the fact that it says physical is very clear, but just inventory would be good too.
Yeah, I think just inventory, because physical, I don't know, it seems weird to me.
It's maybe not necessary, but inventory pretty clearly means like physical stuff.
Yeah.
But I'm also not a nerd, so I don't know if like inventory can mean computer things too.
Yeah, no, yeah, inventory. I would maybe do Consumption scanner, Raspberry Pi. So Clemens is talking about a barcode scanner attached to a small client, a Raspberry Pi, and so you take a bottle out and you scan it, and the bottle gets subtracted from the stock. So you should look at the previous meeting, if someone can put the link in the chat, where they have actually a little QR code scanner attached to a Raspberry Pi, and it works very well for their samples. This idea of taking something out, scanning it, and it gets subtracted is good. Yeah. Okay.
I think Hussein also had a question.
Sorry?
People already created entries with their chemicals. Is it possible to connect them with these compounds?
Yeah. So in fact, you can take an existing resource that is the chemical, and you just add the link to the compound. So the same way that you would add a link to something, you do it with the compound. So in that case, so let's imagine that this doesn't exist. So you have your resource. This is your already existing resource before the update, and someone added a bunch of compounds in there, and you type the name of the compound that exists, and you add it simply like this. Unfortunately, the compound database is incredibly huge, so we cannot just say, oh yeah, let's just import everything at once. So it has to be either manually one by one, or through a CSV file that contains already one line per compound that you wish to import. It's really gigabyte and gigabytes of data. So it's not something like we cannot have the full database. But also what is interesting is that you don't have to add something that is on PubChem, because of course when you're doing chemistry you are inventing new compounds that don't exist in PubChem, and so for that you can add a compound manually. So I will add my cool compound. Okay, click continue. And so here I can add so maybe the molecular formula, maybe molecular weight, and I will say that it's a very toxic and radioactive compound. And so yeah, that's it. I have my compound. It doesn't need to be linked to PubChem. PubChem just makes it easier to import. If the compound exists on PubChem, import it from PubChem. Alexander, just a suggestion, maybe also connect this to the procurement request and trigger a procurement when storage runs low. Yeah, that's a good idea. And John, would it be possible to add a specific box, for instance, 96 well, to know what is in each position? So yeah, I guess this is I guess what we could imagine is that here, when you have, let's say, here you are there, you are in this floor, you are in this room, and when you add the children, you can specify the children so that it could be a 10 by 10 box, or a 96 well plate. No, I don't know. Seems too complicated. Like, I don't know. We'll see. We can think about it, but yeah, we'll see. Okay. Christian, is it planned that the new molecule sketcher will calculate some essential molecular properties? I think it does. So I think if you draw something, I'm doing a great molecule. So if I think here, like there is an option to see, no, to see, yeah. So basically, when you have to click this little Erlenmeyer icon, and it shows you the molecular weight and the mass. And so yeah, it does that. It's actually a very cool project. So this sketcher is done by the people behind Indigo ELN, and so they published this project as an open source software under the Apache license, and we even got a pull request merge. So Mustafa made some changes so that their editor would work into our very restrictive content security policy header that we have on eLab. So yeah, we are pretty happy to be able to move from this not outdated, but I would say limited chemical editor that we had before. Whoops. Well, okay. Yeah, I closed my window by mistake, but I think it's okay because we are reaching the end.
Yeah, lots of good questions. People seem really excited about the new. Oh yeah, this is the big question. When will the new version be available? It is exciting.
When
Definitely.
it's ready.
Not before.
Yeah. So yeah, I stopped giving deadlines, and there will be several alpha and beta version, and it will be also on the demo as soon as we have an alpha. And yeah, as Benjamin says, yeah, soon. It will be this year. I can tell you that. It will be in 2025.
It's a lot of time to work with. Cool. Okay, well, if anyone else has anything they want to say, now's your chance because we're going to close down the meeting. The next one will be in 2 months from now. If you have something you would like to present, please get in touch. I'm also interested in talking to people about just their like day-to-day research experiences and how they use eLab, just so that we can learn a little bit more about the user experience. So if you feel like talking, you can contact me on various different ways, but the main contact email will work. And also, as always, when you're in eLabFTW and you are looking at the little help icon, there's a lot of different ways that you can connect with us. So there's the GitHub, there's links to the documentation and the websites and all that kind of stuff. And we just got Blue Sky, and we're also on Mastodon now, and we're using X a little bit less. So keep up with us there. Please follow us there so that we can just find a new community, as a lot of the scientific community are moving to a new social media environment. And so really hoping to be able to facilitate that being a little bit better than how social media has been recently. Yeah, and thanks so much for being here. Yes, and this is the Mastodon. It's true that we're going to be updating our website very soon, and those links will be easier to find on that website. Okay, thanks everyone.
Okay, bye
Have a nice rest of
everyone.
your day.
Thank you. Bye.
Bye.